Okay, Bismillahirrahmanirrahim. Now we have the tree data structure. We have what? Everybody come to coffees? Okay? And concentrate. So, what we have seen prior to the trees, we have seen the arrays and we have seen the linked list. There were two guys here, and if we have two guys here, why the heck we have the trees now? Okay? So basically, trees take advantage of both of these data structures. What was in the array? In the array, we see that we have a fixed block of elements, right? And in this fixed block of elements, the searching was so simple, addressing was simple, because you know the next block was there only, the next block was there only, and if you want to search it, you have the order, you can use a binary search. You can use what? To make it very faster, right? But in case of linked list, but if you have to insert or delete, because we said we want to switch to the linked list. Why? Because it has a lot of disadvantages. It has like what? Like if you want to insert something, कहीं बीच में insert करना है, पहले ये सारे shuffle करना है इस side, है ना? तो यहाँ से बैठे हैं बंदे 1 2 3 4 5, आपको बीच में करना है, तो ये पहले ये सारे shuffle करने हैं, जगह खाली करनी है, फिर आप डाल सकते हो, right? Similarly, you want to delete something. You want to delete something, then you have to shuffle all the guys there, right? So it takes a lot of time. It's very expensive when we say insertion or deletion. Otherwise, array was good, but it has some limitation on memory and all. Okay, because you have to reserve the memory for the array in advance, and later you need smaller, so it's wastage. Or you have some memory and you need more than that. You can't do that. You have to redefine the array. So we switch it to linked list, which mitigated these problems. All of these problems were removed, and the insertion and deletion becomes much easier because we have to only remove the links if at all I want to insert somebody. If I want to remove somebody, for example, this one remove, I have to only establish the links. I do not have to shuffle like an array, right? Okay? But searching and all, it will be better in this array. Still, if you have a binary search sorted array and you want to do binary search, it will be logarithmic. I have told you, the complexity is logarithmic. It is much better, right? Now, what else if I want to combine both advantages? Advantage of array, advantage of linked list, right? Then you got the right man here, called the tree. The tree actually combines the advantages of all the array as well as the linked list, right? So it's much better data structure than array as well as linked list, because it is linked list with the power of searching of an array. I could say like that, simple terms. It is your linked list with the power of searching of an array, right? So जो binary search जो आप कर रहे हो ना on the algorithm you apply on the sorted array. If I have a sorted array, the algorithm you apply on a binary search. You apply binary, but the structure is an array. Your data is an array, but you are applying the binary search. That is your algorithm. Actually, you are creating a tree out of that array. So then we got a simple idea. Why don't we make our data structure as tree? We are converting this into the tree to make it a binary search and all, right? Why not to create a data structure same as that algorithm, which was the binary search algorithm, right? So our tree is actually the binary search algorithm kind of a thing, right? So our data is arranged in that way that it looks like it's a tree. And tree has an intrinsic property that it's hierarchical, okay? Always, what's a tree? It's a hierarchical, like father has the two sons and it has two sons and goes on. It's called a tree, right? That's called when the data is in hierarchical structure, right? Somebody is this, then this, then this, and so on, right? If we have a sorted array, we could have a tree like this. Like we have 50 here, then we have maybe 30 here, 20 here, 40 here, right? Now we have 80 maybe here. Now 60 is here, 70 is here. Initially it was arranged in the array, as a sorted array like this. As a, what is the plus that?
Next page down. Page.
What is the page here? Yes. Say for example, initially it was an array like this. We have say 10, 20, 30, 40, 70, 80, 60, 70, 80, something like that. Okay? But later on we applied the binary search, converted it into tree. Now I am saying we not store in array, we store in tree itself. If you at all want to store it, for example, what's called the binary search tree, we'll come to the types of trees and all. But I'm just giving the concept why we are going to trees. If we have an arrays and we need to understand this concept. Okay? Now what I am saying is I want to convert this into the binary. So I will divide now. So I will do the division, then this and that. Ultimately what will happen is it will be like the 50 is here, then the 40 goes here, then 30 goes here, maybe 20 goes here, or 45 goes here, something like that. If we have data like that. So it becomes like a tree. It becomes like a tree. Say 50 is here, say for example 80 is here, 60 is on the left, and 70 is on a 90 is on the right of the 80, right? And you want to find 90. Is 90 greater than 50? It has to be on the right side. Is 90 greater than 80? It has to be on the right side. Got it. Bingo. In the first iteration, you see it is on the right. If अगर 1 crore elements यहाँ से होंगे, they are all not to be seen. My element is on this side. This is what you do na binary search. You remember the binary search? Binary search किया था हमने?
Yes, sir.
Binary search किया हमने?
Yes, sir.
Okay. Similarly, if you go on this side, right? 90 is greater than this. So divide this. जितने भी elements यहाँ पे होंगे, I don't want to